when we talked about breaking a vector down into components, as long as you know the angle off the positive x-axis, to break a vector down into components, if you knew this was, 8 newtons of force right here, you could find the x component using which function? Cosine. So you could say the cosine of 40 equals x over 8, which means you'd multiply by 8 to find x. And if you're looking for y, then it's opposite over hypotenuse. So you would do the sine of 40 equals y over 8, and you'd multiply by 8 to find the sine. Okay? This is how you will find the components of any vector. If you take the length of the vector, or the magnitude, okay, and you multiply that times the cosine, that'll give you the x component, and the sine, the y component, as long as the angle you're using is with the positive x-axis. So, yes? Okay, a vector, again, this was part of the lesson you missed, but a vector is has to have magnitude and direction, which is the difference between a vector and a scalar. A scalar is when it doesn't have both quantities. This kind of talked about that it was a vector, looks like a ray, but it actually has length measured from the tail to the tip, or the tip to the tail, okay? It goes from the very end of the arrowhead. Some books will write this little line at the end to show that it's a vector, not a ray. But it has to have magnitude and direction, okay? And you can, like everybody said, watch the video if you're still confused about that. But so here's just a quick example. It said 2.5 centimeters per hour at a bearing of, this was off of north 50 degrees towards the west. So then we said off of the positive x-axis, it was 140. We typed 2.5 centimeters per hour times cosine of 140 and sine of 140, and these were the horizontal and vertical components. All right, then we get into some really crazy business. And we're going to do number 8 on 1B. Okay, and I'm going to do this in 2 parts. Or I'm going to do the same problem twice, I should say. I'm going to do this as a component question, and then I'm going to do it as a parallelogram question, which is the way they teach them in physics, and not my favorite way at all, because you have to be able to draw the diagram fairly accurately, and we all know how good I am at that. Okay, this starts out with the helicopters moving 15 degrees north of east. When it says of east, it means it's measuring off of east towards the north 15 degrees. And the magnitude of the vector is 52 kilometers per hour. So to find the components, what are we going to type, guys? The length is 52 times the cosine of 15, and 52 times the sine of 15. And I'm not going to bother with those decimals yet because we're going to use them in a second to add it, so I'm just going to leave it. Then that was the helicopter. The other thing that's happening is the wind is blowing, and I'm going to do this on a separate vector. I'm not going to even try to put them together until we've come up with the components. The wind is 30 kilometers per hour from a bearing of 250. Okay, if you're gone Friday, there's so much going on with that question right there. First of all, a bearing, when they use the word bearing, it means off of north in a clockwise direction. For example, this is how an air traffic controller keeps track of everybody. They measure off of north going around, is my understanding. Like I would know, but if they went around 250 degrees, okay, but it says it's blowing from a bearing. Well, here was my little picture on Friday. When it says from, it's like the wind is blowing it through the origin. The little note here says when it's blowing from, the vector is drawn towards the north-south line. When it is blowing at a bearing of 125, it's blowing away from the north-south line. So, sorry, can't find the right one. For this question, if the wind is blowing from a bearing of 250, Mr. Wind is over here, okay? He's blowing this way. So, while the 250 goes all the way around to there, he's actually blowing the aircraft back into this quadrant. All right, so if 250 went around to here, guys, can you tell me either side of that blue line? Okay, this would be 20, right? 250 degrees, another 20 would be 270 or 3 quadrants worth. So if this is 20, then the angle over on this side when we blew it past here was 20 degrees. So we're going to do 30 kilometers per hour on that vector. We're going to do 30 cosine of 20 and 30 sine of 20 to break it down into components. When you have two separate sets of components, to find the components of the resultant, which is what happens when you add them together, you add the x components and get a number, and you add the y components and get a number, and those will give you the components of the resultant. So if you type 52 cosine of 15 plus 30 cosine of 20, I got 78.4. Anybody get that for the first one? Yes, degrees. And then 52 sine of 15 plus 30 sine of 20, 23.7. Please be typing so that you know where I'm getting these numbers. Otherwise, you're like I'm doing magic. You do have to close the parentheses here, but I'm adding these two numbers together to get 78.4, and then these two numbers to get the 23.7. Did anybody not get those two? All right. So what has happened is the resulting vector looks like this. 78.4 and 23.7 are the components, but the vector would be this. We need its magnitude, which means length, and its angle. How do we find the length of that side, guys? Pythagorean theorem. Anytime we're looking for magnitude and we're going from the components to find the magnitude, you're just doing Pythagorean theorem. So we're going to have square root of 78.4 squared plus 23.7 squared. I got 81.9. Anybody else get that? Okay. The length is in kilometers per hour because that's what these two were measured in. So that's the magnitude when it asks for magnitude, okay? Or the resulting velocity in this case. The direction, if I were to ask you to find this angle right in here, theta right in there, we could do inverse tangent, yes? Y over x or opposite over adjacent. So we're going to do inverse tangent, 23.7 over 78.4. I got 16.8. Did anybody else get that? Okay. I don't like this question because it's not clear what they want. If I put this on a test or quiz, I would make very clear at the end how I wanted the angle to be measured. And normally I would tell you, you measure it however they gave you the angles. But remember, one of the angles was north of east and the other was a bearing. So they're not clear which way they want it stated. If we leave it 16.8, that is the angle off of east. So we could write north of east. What if we wanted the bearing, guys? Yes, if this is 16.8, the bearing would be off of north, so it would be 90 minus that. What is it? 73.2 is the bearing if off north. I didn't write that well, but you get the idea if it had asked for that, okay? Again, I would not ask that question on test or quiz unless I specifically stated which I wanted. And normally I would ask them both in the same way in the question. All right, we're going to redo this question using the method taught in physics. Yes. Yes? Yep. It's because they're very close together. Yeah, if you had added these straight on, guys, you would have gotten 82 is her point. And that's because these are almost pushing each other. To see how close the angle is, 15 degrees, 20 degrees. Okay. That's also part of the reason it makes the second half, this method, very difficult in my mind, because the angles are very close together. Okay. I'm going to try to explain this. If you've had physics, this is the way they do them in physics. I don't like this method, so I'm going to do this example, okay? Helicopter 15 degrees north of east. So the helicopter is this blue line right here, 52 kilometers per hour. 15 degrees is the angle in here. All right, the wind is a 30 kilometer per hour wind blowing from a bearing of 250. So the 250, I don't even know where to write that, but it's all the way around here, right? But the wind is blowing from there, so it pushes the vector through here. Now, the method that this method is called tip to tail. Tip to tail means you can't have both of them starting at the same point. Just see how I have the blue going this way and the red going this way. What you have to do is slide the red and use what's called a parallel vector out to the end of this. So I have attempted to take this red vector and slide it out to the end right here, and it's parallel. Now there's a whole bunch of geometry going on here. All right, first of all, let's label it. It was 30 kilometers per hour, so when I slide it out here, it's 30 kilometers per hour. All right, the actual resultant is from the origin to the end of this red. So that's what we're trying to find, the length of X right there. If I were to redraw that nasty little picture over here and a much bigger, this is 52. This is 30. And we're going to spend some time trying to figure out this angle so that we can find X by law of cosines. Does that make the picture a little more understandable? But this, how we find that angle is the really nasty part. Okay, guys. Do you remember geometry when you did this and you had these angles are equal by alternate interior angles? Okay. If I were to redraw a little tiny north-south line right here, which is what they do in physics, there's a Z right here. Watch carefully. That green to this blue to this green right here, yes? There's a little 15-degree angle under there. You see it? Okay, I'm going to undraw that mess and say that below here is 15 degrees. Now, what else we know is that between, okay, if this was 250 around to here, we decided a few minutes ago that this was 20 in here. Remember? So that's between the horizontal line and here, which up here would be also This one is 20, guys. The red to here. You seeing where I am, which is here. Okay. I need what's the rest of this then? Horizontal to red was 20. Red all the way around to next horizontal line would be 160. Okay, so 160 and 15 makes this whole angle in here 175. Yeah. Okay. Now we're going to do law of cosines. I'm just going to use this picture over here because this one is a hot mess. So we're going to use 52 squared plus 30 squared. X squared equals, minus 2 times 52 times 30 times a cosine of 175. Okay. Type, and square root at the end quickly. Shouldn't be a big surprise. But hopefully it turned out 81.9. Did anybody not get 81.9? Okay. Should be the same as the other method. All right. Then what we need to find, and I'm going to use my exaggerated triangle again. We actually need to find, look over here, guys. Can you see where my cursor is? We need to find this little teeny tiny angle in there. Okay. So I'm going to use my exaggerated one. We're going to use law of sines to find this over here. So this was 81.9. And that's across from the sine of 175. In the same way that the sine of that little teeny tiny angle is across from 30. So 30 times the sine of 175 divided by 81.9. Inverse sine of that. It's a lovely 1.8 degrees in there. Okay, if that little tiny angle in there is 1.8 degrees, that's how far the wind is blowing it off course. Okay? Because it was flying 15, but it's been blown off 1.8. So it's actually flying a total of 16.8 degrees north of east. Is that the same thing we got the other way? Okay. Yes. No. Nope. But I wanted to tie it to physics, and if you want to do problems that way, you can do them that way, and you can, and if you can't figure it out, I can help you. I went back and I did them all both ways on the homework, so was sure I could explain them both ways, okay? That being said, I'm going to stick with the component method, especially because there's a couple questions where you have to add 3 vectors. Component method, all you do is vectors A's components, B's components, C's components, you add them all up, get the components, magnitude and direction, and you're done. Okay? Yes. Yeah, oh, I'm sorry. All you would do is if the black line right here, Claire, is 16.8 degrees north of east, the bearing would be going that way. So you would just do 90 minus 16.8 because it would be off of north instead. All right? That would be the bearing. Yep. All right, guys, this is what I would like to do. I would like to go to, you have 2 things to do tonight, or part of the assignment is to do the worksheet 2, but part of the assignment is book work. We have more time to go over questions on this tomorrow and get ready for the quiz. So my thinking was I would do some of the book work icky problems with you, and then tomorrow if you have questions on the worksheet, I can do those. Does that make sense? All right, because I know some of you otherwise won't even look at all the book work. All right, so I would like to, I'm going to do this kind of a funky order. I'm going to do 22 and 23 and 24. This is the vector stuff. Yeah, page 488. Thanks. Okay, page 488. I'm going to do some of these, and then I'm going to go back and do 19 and 20, but some of these are super easy, so I just wanted to start with the easy stuff here, okay? 18 newtons. If you walk directly forward, or the force pushes something directly forward, but then there's another 20 Newton force pushing it directly backwards, where does it wind up, guys? Yeah, or you can just say 2 newtons backwards. The resultant force is 2 newtons backward. I'm fine with that. Now do you see why everybody would have been like, this is hard, I don't get it, because it's so easy, you just think it's too easy. 100 meters, you walk due north, and then some reason you turn around, went 350 kilometers or meters due south. Where did you wind up? Yep, that's all it wants. Okay? Now that would be the end of the fun. Okay? Starting with 24, we have to figure out what the resultant is, both the magnitude and direction. I have it on another slide here so we can... Anybody remember what this meant? Why they gave us 3? Yeah, it's off of north, and I don't know, I can show you where it was in the notes. There was a little thing in the book that said... It says here, so true bearings are always 3 digits, so a direction that measures 25 off of north will be 025, okay? Just so you see where that's coming from. And then I did explain that at one point. All right, so I'm going to draw this as 2 separate and then find the components. 10 pounds of force at a bearing of 025 means 25 degrees off of north. But when I go to do the bearing, what do I have to do? Or I'm sorry, when I go to do the components, I totally said that wrong. I need this angle. So I go, is that 65? Because I did some of these wrong in my head, then had trouble on the homework. So it's going to be 10 times the cosine of 65 and 10 times the sine of 65. Now, do you want me to draw that and talk about y again? Because you have a right triangle here. This is your x. This is your y. Everybody's okay? All right. This one, it says 15 pounds of force at a bearing of 045. So this is 45 degrees in here and 15 pounds of force. I'm thinking these are pretty much going to help each other along, yes? They're not working against each other. They're kind of going in roughly the same direction. All right, so how do I write the components of this one? Well, if that's 45, this angle is also 45. So I'm going to type okay. Now I've got the component form for both. I add the 2 x components and get a number, and then I add the 2 y components and I get a number. Anybody helping me out? Okay, I couldn't tell you because I didn't even turn my calculator on. I started typing. That's helpful. 14.8 for this one, guys. 19.7. Okay. That means what the resultant looks like is a vector that is going over 14.8, which I realized that that was not a good picture at all, and up 19.7. Those are the components of it, but this is the actual path. Its magnitude is just the length, so what are we going to do? Pythagorean theorem, always. And it will have the same label as the 2 forces did, so pounds of force. Did you have a question, Sarah, or did I round something goofy, or you were fine? Okay. 24.6, did someone else get that? Okay, that is the magnitude, but the directions to this section back here also said the direction. Now, how do you think I want the direction stated for this question? bearing off of north because both of these were. Does that make sense, guys? However they ask it in the question, unless they ask it two different ways, and then you can answer either way unless I specify. All right, so we're going to find this angle with inverse tangent first. Opposite over adjacent, or y over x from down here. It's always tangent y over x. So inverse tangent, 19.7 divided by 14.8. I got 53.1 or 53 degrees roughly. Okay. Is that our bearing? No, because that was in here. So the bearing out here, what is my geometry? Yeah, 90 minus 53, or 37 degrees roughly, or 037 bearing. Not too bad. A lot of steps, a lot of calculator typing, a lot of room to make a mistake when you're typing on your calculator, but overall not too bad. Okay, I'm going to skip 25. Basically, you have your components already, right? 17 straight east, 16 south. Just do Pythagorean theorem and inverse tangent. You'll be fine. And that one you can give me a direction off whatever. You know, how many south of east, east of south, whatever you want. I don't care. All right, I'm going to do 26. It says you have 15 meters per second squared. That's a acceleration. Is that right? I think that's an acceleration at a 60-degree angle to the horizon. So something is doing a 60-degree angle here, and it's 15 meters per second squared. To break that into components, do I need to change the angle? Nope. So I just do 15 cosine of 60, 15 sine of 60. Now, at the same time, another force is 9.8 meters per second squared straight down, which is actually the acceleration due to gravity. Now, if we wanted to be fancy, I suppose we could use like negative 90 degrees, right? But don't you know the components of that? What would cause you to go to that point right there? Over 0 and down 9.8, does that work? And like I said, you could do 9.8 cosine of negative 90 degrees because it went here, right? And 9.8 sine of negative 90, and it would work. All right, what are we going to do next? Add those together. Anybody get an answer for me? Okay. What quadrant am I going to wind up in? Because these are kind of working against each other this time, right? But this tells me right here that I'm going to wind up here somewhere, right? 7.5 over and 3.2 up. But the actual distance, or in this case acceleration, is going to be Pythagorean theorem. It's going to be calculated using Pythagorean theorem, I should say. I got like 8.1 or 2-ish. Yeah, I think the book had 8.1 because I think they rounded differently, but we're all good. Meters per second squared, and that's our magnitude. All right. If we want to find out the degrees above the horizon right there, can we just do what? Inverse tangent of 3.2 over 7.5. Oh, I don't know what I typed. Somebody have an answer? 23.1? And that's off the horizontal, which is how they gave us this one. So it seems okay to me. All right. I'm going to go back because there's a couple tricky ones on 20 and 21. Yes? Okay, let's talk about 20. It says a charter boat leaves port on a heading of north 60 degrees west for 12 miles. Okay. Again, this was discussed on Friday. The same thing here. It says when you use these capital letters like this, it's east or west of the north-south line. So they want you to start off the north-south line. So for this one, off of north, we go 60 degrees towards the west. Everybody okay? Off of north, we're going around 60 degrees towards the west. Okay, for components, and we're doing it 12 nautical miles, which I have no idea what the abbreviation for. I'm just going to call them miles for now. All right, we have, for components, we need off the positive x-axis or we won't get the right signs. So what are we going to use? Plus 90 would be 150. Everybody okay? 12 cosine 150 and 12 sine of 150. And that's the charter boat. Oh, then that's his first leg of his trip. Got it. Then what happens is the captain decides to change course. And he goes a bearing of off of north 25 degrees towards the east. Okay, the 25 is between the north and the path towards the east. And he does this for 15 nautical miles. Now, if we were actually doing the other method, you would have to move this to the end here to see where he winds up, okay? But the method we're doing, we're just going to type 15 cosine of what, though, guys? $90 minus 25 is 65. Did you draw it in the wrong quadrant? Whoops, sine, not cosine. Okay. Adding those two together, where did the ship wind up? Do you have to close the parenthesis if you type it in all at once? On the angles here. I got negative 4.05 or something. 19.6. Sounds good. Okay, so where did they wind up, guys? Yeah, they wound up over here somewhere, okay? They're negative 4.6 and 19.6. So how far away are they having to go straight back is the question, okay? So we need the magnitude. And again, you're going to want to put the negative number in parentheses or just use 4.05. So using Pythagorean theorem, what do we come up with for the magnitude? Oh, it was 06, 4.0. We'll go with, thank you. I don't know. I got so many decimals everywhere. Does it come out about 20, guys? I got about 20 nautical miles is how far they got to drive the boat to get back. Okay. Now, this is the one that's going to mess you up. Where does the calculator do inverse tangent? Do you remember we did the colored unit circle? Calculator will give you an inverse tangent in either quadrant 1 or 4. So when I do inverse tangent here of 19.6 divided by negative 4.05, where does the calculator think we are? Fourth quadrant, because it had, I put the negative on, okay? So 19.6 divided by negative 4.05. I got negative 78.3. Yes? Negative 78.3. You have to know by those coordinates of the component that you're not in that quadrant. If you think you're down here 78.3 degrees, how are you going to move all the way around to the other quadrant? Add 180. Okay? So if I add 180, whoops, not 108, half hour. 101.6, 0.7, we'll go 101.7. Okay, great. So this is 101.7. Is that what they wanted? How are we going to figure out how far off of north? Yeah, just subtract 90 to find that little bitty angle in there. So if we take off a 90 off of that answer, we get what? 11.7 degrees. And that was what? How do we write that? Off of north. And if we wound up in quadrant 2, it was towards the west. Yeah. Well, if our calculator just understood what quadrant we wanted it to be in, it would be so much nicer, but it doesn't. So we got to be a little smarter than the calculator. All right. Let's see if we can get 21 done. Okay? Unless someone has something else they wanted me to do. We're good? Okay. Nick and Lauren hiked 3.75 kilometers to Lake 55 east of South from their campsite. When they say of South, that means off of South. They were going 55 degrees towards the east. Off of South, 55 towards the east. So what do we want to measure? Use this number. Negative though, right? Otherwise we won't get the coordinates in the right quadrant. All right, and it was 3.75 kilometers, so we're going to do 3.75 cosine of negative 35, 3.75 sine of negative 35. All right, second half of the story. Then they hiked 33 degrees west of north, so this way, 33 degrees for some distance. What angle are we going to use on that one? 90 plus 33, which is 123. And that distance was 5.6 kilometers. Okay, type, type, type. I got basically 0. Yep. All right. So where did they wind up? 0, 2.5, right here. So they wound up what? 2.5, right? If we do Pythagorean theorem, we're going to get 2.5 kilometers due north. Look, guys, if I moved this vector right up here, does it look like they could wind up due north of where they started? They went this way. Okay. I was doing well for a minute there. Okay. They started here in the center. They walked this way. Then they did this. They turned and walked that way. So they wound up due north. Okay, right there. All right. That was my attempt. Any questions? My goodness, I have time to start another one. You know what? I want to do an easy one for those of you who are gone Friday. Oh, did I? It was due south. If you did inverse tangent, it's undefined, so you wouldn't get an answer, but it's because it's 0, 2.5. No? This was straight. If you went over 0 and down 2.5, you're due south. But they were, it's up 2.5. That's why it's due north, not south. Yeah, don't listen to me. I want to go back. There's some that just ask for the components, guys. And I just don't want you to be confused. Like here, if you're doing this question, number 39, it says draw it, okay? It's off the north, 49 degrees towards the east. And label, and you don't have to use a scale. You just write 1.5 centimeters. I said you don't have to use a scale. Then it says find the magnitudes of the horizontal and vertical components. That's what we've been doing. This angle would be actually 41. Does that seem right? So you will type 1.5 cosine of 41, and that will be the horizontal component. And then you'll type 1.5 sine of 41, and that will be the vertical component. Does that make sense? Some of you weren't here when we did those easy ones, and you're going to read the directions and go, ah. Because yes, this is number 39, and it's easier than the ones we were doing. So tonight, work on worksheet 2 and any book work that's up there, because it's all due Wednesday, and I'm going to go over questions tomorrow.